There is no specific calculation formula exclusively for outbuildings. The load calculation relies on the intended use of the building and the electrical equipment that will be installed. Considering the use of number 4 aluminum wire to feed a 60 amp subpanel, it is correct that number 4 THHW or THWN aluminum wire is suitable for this purpose. The 50 amp limitation seen for number 4 THHN aluminum wire might be referring to the ampacity of the wire when installed in conduit, where heat buildup necessitates dirting. Typically, the feeder size is determined by the calculated load. The National Electrical Code, referred to as NEC, does permit upsizing the feeder to the next standard breaker size, provided the ampacity of the wire is not exceeded. Given an estimated load of 20 to 25 amps, number 4 THHW or THWN aluminum wire could be used to feed a 30 amp subpanel, or number 4 THWN aluminum wire could be used to feed a 40 amp subpanel. Both options provide ample capacity and accommodate potential future load increases. It is crucial to ensure that the subpanel and circuit breakers are rated for the correct amperage. Protecting the wires with suitable conduits is necessary, taking into account the environment and any potential hazards. A proper grounding system for the building and its electrical system is essential. Always comply with all relevant electrical codes and regulations to ensure safety and proper functionality. The NEC is a comprehensive set of standards that governs electrical installations. It provides detailed guidelines on conductor sizing, overcurrent protection, grounding, and wiring methods. Familiarity with the NEC is crucial for safe and code-compliant electrical work. When calculating the electrical load for an outbuilding, several factors must be considered. Firstly, account for general lighting. Estimate the wattage required for lighting fixtures based on the area to be illuminated. For fluorescent tape fixtures, determine the wattage per fixture, including the ballast, and multiply by the number of fixtures. Secondly, assess receptacle loads. Receptacles are used to power various equipment and appliances. The NEC specifies general use receptacle loads based on volt-amp per square foot. Determine the square footage of the outbuilding and multiply by the appropriate volt-amp per square foot value. Thirdly, consider any specific appliances or equipment. If the outbuilding will house specific appliances or equipment, such as a workshop with power tools or a heating or cooling system, include their power requirements in the load calculation. Obtain the nameplate ratings of these devices to determine their volt-amp or wattage. Fourthly, account for motor loads. If the outbuilding includes motors, such as those used in pumps or compressors, calculate the motor loads according to NEC guidelines. Motor loads are typically higher than the nameplate ratings due to inrush current during startup. After determining all the individual loads, apply demand factors as permitted by the NEC. Demand factors recognize that not all loads will operate simultaneously at their maximum capacity. Applying demand factors can reduce the overall calculated load, resulting in a smaller service size. Once the total calculated load is determined, select the appropriate wire size and overcurrent protection for the feeder. The feeder must be sized to carry the calculated load without exceeding its ampacity. The overcurrent protection, such as a circuit breaker, must be sized to protect the feeder from overload. Refer to NEC tables for ampacity ratings of conductors based on their material, insulation type, and installation method. When using aluminum conductors, ensure that the terminals and connectors are rated for use with aluminum. Aluminum conductors have a higher resistance than copper conductors, so proper termination is crucial to prevent overheating and connection failures. Grounding is a critical safety aspect of electrical installations. The grounding system provides a low impedance path for fault current to return to the source, allowing the overcurrent protection to operate and clear the fault. The outbuilding must have a grounding electrode system that is connected to the service equipment. The grounding electrode system can consist of a ground rod, ground plate, or underground metallic water pipe. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. In addition to the grounding electrode system, all metallic enclosures and equipment must be bonded together to create an equipotential plane. Bonding ensures that all metallic parts are at the same potential, reducing the risk of electric shock. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device. Conduit is used to protect electrical conductors from physical damage and environmental factors. The type of conduit used depends on the location and application. Rigid metal conduit, intermediate metal conduit, and electrical metallic tubing are commonly used for outdoor and underground installations. Non-metallic conduit, such as PVC, can be used in corrosive environments. When installing conduit, ensure that it is properly supported and secured. Use appropriate fittings and connectors to maintain the integrity of the conduit system. Sealing conduit can prevent moisture and gases from entering, which can damage conductors and equipment. Proper installation practices are essential for a safe and reliable electrical system. Follow the NEC guidelines for wire bending radius, conductor fill, and support spacing. Avoid damaging conductors during installation by using appropriate tools and techniques. Always disconnect power before working on electrical equipment. Use a voltage tester to verify that the circuit is energized before touching any wires or terminals. Wear appropriate personal protective equipment such as safety glasses and gloves to protect against electrical hazards. If you are not comfortable working on electrical systems, hire a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to perform the work safely. In summary, calculating the electrical load for an outbuilding involves considering lighting, receptacle loads, specific appliances, and motor loads. Apply demand factors as permitted by the NEC to reduce the overall calculated load. Size the feeder and overcurrent protection according to the calculated load and the ampacity of the conductors. Ensure proper grounding and bonding to protect against electric shock. Use appropriate conduit to protect conductors from physical damage and environmental factors. Follow safe installation practices and comply with all applicable electrical codes and regulations. Always prioritize safety when working on electrical systems. Now let's delve into some more detailed aspects of electrical calculations and code requirements for outbuildings. When determining the lighting load for an outbuilding, consider the type of lighting fixtures being used. Fluorescent fixtures, like the Tates mentioned, are energy efficient but require ballast to operate. The total wattage of a fluorescent fixture includes the lamp wattage plus the ballast wattage. LED fixtures are becoming increasingly popular due to their high efficiency and long lifespan. LED fixtures typically have a lower wattage than fluorescent fixtures for the same light output. When calculating receptacle loads, the NEC specifies a minimum volt amp per square foot requirement for general use receptacles. This requirement ensures that there is sufficient capacity for powering various equipment and appliances. The volt amp per square foot requirement varies depending on the type of occupancy. For example, a workshop may have a higher volt amp per square foot requirement than a storage building. When calculating the load for specific appliances or equipment, obtain the nameplate ratings of these devices. The nameplate rating indicates the volt amp or wattage that the device consumes. For motor loads, the NEC provides specific rules for calculating the ampacity of conductors and the size of overcurrent protection. Motor loads are typically higher than the nameplate ratings due to inrush current during startup. The NEC requires that the conductors supplying a motor have an ampacity of at least 125% of the motor's full load current rating. The overcurrent protection for a motor must be sized to protect the motor from overload and short circuit. Demand factors are used to reduce the overall calculated load by recognizing that not all loads will operate simultaneously at their maximum capacity. The NEC provides demand factors for various types of loads, such as lighting, receptacles, and appliances. The demand factor is a percentage that is applied to the total load to determine the reduced load. For example, a demand factor of 80% means that only 80% of the total load is expected to operate simultaneously. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The ampacity of a conductor depends on its material, insulation type, and installation method. Copper conductors have a higher ampacity than aluminum conductors for the same size. The insulation type of a conductor affects its ampacity because different insulation materials have different temperature ratings. The installation method of a conductor affects its ampacity because conductors installed in conduit have a lower ampacity than conductors installed in free air. The NEC provides tables that list the ampacity of conductors based on these factors. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect conductors and equipment from overload and short circuit. The overcurrent protection device must be sized to protect the conductor from exceeding its ampacity. The NEC provides rules for selecting the appropriate size of overcurrent protection device. Grounding is a critical safety aspect of electrical installations. The grounding system provides a low impedance path for fault current to return to the source, allowing the overcurrent protection to operate and clear the fault. The NEC requires that all electrical systems be grounded. The grounding system consists of a grounding electrode system and an equipment grounding conductor. The grounding electrode system is a connection to the earth, such as a ground rod or a metallic water pipe. The equipment grounding conductor is a conductor that connects the metallic enclosures of electrical equipment to the grounding electrode system. Bonding is the process of connecting all metallic enclosures and equipment together to create an equipotential plane. Bonding ensures that all metallic parts are at the same potential, reducing the risk of electric shock. The NEC requires that all metallic enclosures and equipment be bonded together. Conduit is used to protect electrical conductors from physical damage and environmental factors. The NEC specifies the types of conduit that are permitted for various applications. Rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and non-metallic conduit are commonly used. The type of conduit used depends on the location and the type of environment. Proper installation practices are essential for a safe and reliable electrical system. The NEC provides detailed guidelines for wire bending radius, conductor fill, and support spacing. It is important to follow these guidelines to ensure that the electrical system is installed correctly and safely. Always disconnect power before working on electrical equipment. Use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. Wear appropriate personal protective equipment, such as safety glasses and gloves, to protect against electrical hazards. If you are not comfortable working on electrical systems, hire a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to perform the work safely. Remember to consult the latest edition of the NEC for the most up-to-date requirements and guidelines. The NEC is a living document that is revised every 3 years to reflect changes in technology and safety practices. Staying current with the NEC is essential for all electrical professionals. In addition to the NEC, local codes and regulations may also apply. Check with your local building department to determine if there are any additional requirements for electrical installations in your area. By following the NEC and local codes, you can ensure that your electrical installations are safe, reliable, and code compliant.